we can do a quick conversion and see that actually this is 0.08%. Okay, that's 0.08%, 80 milligram percent. We don't worry about doing the conversion. You can do it on your own if you want, but you'll see that here, after 4 drinks, this individual is going to be at the legal limit within about an hour, and then he's going to not drop, and it'll immediately drop down from there, but over a long period of time. We won't go into all the different measures of intoxication, the effects that it has on the body. That can come into some other classes discussion. But what we should bear in mind is that these limits that we talk about really hinge on the kind of beverage that you're drinking, the size of that beverage, your own weight, right, and the amount of time that you took to drink that beverage, and the amount of time that has elapsed since you drank those beverages. So you have to take, I guess the point is that we take this picture with a grain of salt, keeping in mind these variables: beverage, size, type, weight, and time. So that's intoxication. Very interesting, I think. But there's negative effects of ethanol in the body. Are there positive effects? This gets a lot of play in the media nowadays, and what we can clearly see from this kind of a study. Here's another study that I've stolen from the Journal of Epidemiology and Community Health, relatively recent study. This is just looking at a very large population. You can go look at the study if you want the details. They're just looking at the survival rate, how many people live in the study up to a particular age, and they got 3 different categories: and individuals that drink wine, individuals that drink beer or spirits, probably not excluding wine, and individuals that drink no ethanol whatsoever. And what we see, this is a fairly easy chart to interpret, right? 50, most of the people are still alive, but as we begin to age, our population that's still alive goes down, 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 and then as we pass 90, we're about down to a population of 0. The key that you want to take home here is the difference, right, in the size of this population with and without the consumption of ethanol. The other way to look at it is you can say, well, 50% of the population that doesn't drink ethanol is dead by 76, whereas the 50% of the population is still alive at 81 for those individuals that drink wine. So there are benefits, and they're complicated, and they're still, again, a matter of intense study. But what we can say is that consumption of moderate amounts of ethanol can decrease our rate of cardiovascular disease. Why is this longevity? What's the cause of this increased longevity? Again, it's not clear, but there's a correlation, and I want to make it clear the difference between a correlation, I'll just write that down, versus causation, without going too deeply into what that means. Right? There's a correlation between moderate alcohol consumption and longevity, and perhaps that's because of molecules that wines, particularly red wines, are high in, and we've talked about these previously, these phenols and polyphenols. Okay, so again, organic chemistry lesson, you can take it at phenols and polyphenols can be act as antioxidants and can result in increased longevity because of their presence in wines, especially red wines. But if you want to go a little deeper, let's look. This is a phenolic compound. It's not a polyphenol, right? It's just there's a single phenol, so we don't call it a polyphenol. So there's that benzene ring with a hydroxyl or an OH group. That's a phenol. Now, what is this guy? Oh yeah, I should make sure that you know that this is vanillin. Now, I'm cheating a little bit. Vanillin is not found in a very high concentration in red wine. It is found in higher concentration in oak barrels. And you can imagine that those of you that have had chemistry classes and organic chemistry classes will remember that ethanol is a pretty good solvent. So when you fill up a wooden barrel with ethanol, something that you're very likely to do is to extract those compounds that are present in the barrel with the ethanol, and they wind up in whatever liquid is stored in the barrel. In any case, the point being that there are benefits to alcohol consumption. They're pretty well established in the literature, and it is believed that many of these benefits derive from the presence of these phenolic compounds through a whole slew of different means. All right. Let's talk a little bit about ethanol in food, and I'm really not going to talk too much about this. We'll encounter ethanol in various places as we proceed through the rest of the semester. But let's just see that alcoholic beverages can add a variety of flavors to our foods. And if we're thinking about wine, some wines are very sweet and contain a high amount of sugar, so we can add sweetness to our food, whatever that might be. If you happen to add wine to a tomato sauce, for example, some alcoholic beverages are high in savories like umami. So this is one of our flavor classes. Umami seems to be related to well, you've probably all heard of MSG, right? Monosodium glutamate. Here's glutamic acid. Remember, I talked about glutamic acid, or I talked about pyruvate and pyruvic acid. Well, glutamic acid is the same as glutamate. We just draw it like this instead, right? There's there's glutamic acid now, and monosodium glutamate, providing a savory flavor, which is wonderful. But they can also provide acidity and bitterness. I won't talk so much about acidity, but let's talk again about these phenolic compounds. When we talk about bitterness, this happens to be an alpha acid from hops. I'm introducing it to you because we're going to see it again in a little while, right? We won't talk specifically about what this molecule is, but we've talked about the bitterness of the phenolic compounds in previous lectures. I'll remind you especially of the phenols found in olives that have to be degraded before they're consumable. How do they get degraded? Oh, fermentation, right? So again reminding you about how important fermentation is to everything that we eat, or so much that we eat anyway. So there's a whole slew of flavors possibilities that we get through our introduction of ethanol to our foods. We also get aromas, of course, and there are plenty of aromatic, and I'm using that in the smell sense, not the organic chemistry sense. Aromatic molecules in alcoholic beverages. The aromas usually arise from volatile compounds. What does that mean? That means they evaporate easily. They evaporate easily. They're volatile. They vaporize. And these volatiles, as I mentioned before, can be extracted by ethanol. So ethanol is a good solvent. So it can be used to pull these aromatic compounds out of whatever food item you happen to be working with, whether it's tomatoes or meats or any number of other possibilities, and the ethanol can serve to bring more of those out of the food. But of course, too much can lead to an alcohol aroma, which might be a negative factor in your food. Maybe not, but oftentimes too much is too much. So we see we see alcoholic beverages and alcohol itself as being important in many different food items. All right, I'm going to pause there, and we'll move on to our next lecture in a separate episode.